All right. Hey, everybody, and welcome to another episode of React Wednesdays. My name is TJ VanToll, and I work as a developer advocate at Blues Wireless. And if you're new here, React Wednesdays is a show we do every Wednesday, as the name sort of implies, where we bring in cool and interesting people from around the React, from around the JavaScript, from around the front end worlds, and have them show us, teach us something interesting and very cool. So if you are new here, you can go to taleric.com/react-wednesdays, which I'll toss in the chat here on Twitch in just a second. And if you're watching on YouTube, it'll be down in the show's descriptions. You can find information on previous episodes if you want to watch those upcoming shows we have scheduled. You can add the show to your calendar and things like that if you would like as well. So check that out. Today's episode, though, we have a really fun one scheduled. We are talking with Denjell, who I'm going to go ahead and bring on here from Tauri, a very exciting app. So Denjell, how's it going? Why don't you start by just introducing yourself, telling people who you are, and a little bit about what Tauri is as well.
Sure. Thanks, TJ. Hey, everybody out there in Streamland. And I'm calling in from Malta, where I usually live in the winters, spring, and fall. The summer is just too crazy. And I took a weird path to getting into software engineering. I actually started as an artist, as a fine artist. I got my degree in the U.S. and then I moved to Germany and went to Bauhaus. And I was outing my age here. I was born in the 70s, and my first computer was a Commodore 64. And that kind of love for getting your hands dirty really always stuck with me. And then when I was at the university in Germany, I really got into this kind of just do it yourself thing. My thesis, I built some video projectors and made a real-time analog holographic projection system and used that to present the work to my thesis committee. And I mean, nowadays it sounds trite, but this was before we really even had video chat. You could maybe use Skype to make a phone call. And of course that sort of branded me as, oh yeah, just call up Denjell, he'll help you figure out whatever it is you need to do. And I kind of got into this. Sure, okay, I can make a video server for your art project, or auto starting, auto looping, USB key driven playback for a gallery. And I've always been in this sort of community organizing realm, being a volunteer and teaching people about, culture. And of course, like everybody here probably, if someone knows that you do anything like IT, you end up fixing the router.
Yep. Or printer.
Can you please make it? Right. Yeah. And after a while, you realize Bash is actually a programming language. You've been on Linux for a decade, and you're picking up other languages. You pick up some JavaScript, a little bit of Python, and all of a sudden, I found myself in a community called Quasar, which is a Vue.js based system for making apps. And the claim to fame over there was that you can make a SPA, a PWA, an SSR, an Electron app, a capacitor app. All of it went from the same CLI. And it also came with great components, all like Material Design 2.0. And it was a challenging and fun time. But then my friend and I, Lucas, we were just kind of like, God, these apps are so big, and we're never going to get them on the Pure OS store. That was our big thing back then, getting it onto the Purism's app store for their devices. And obviously, they can't accept Electron because of licensing problems or perception. I don't want to go down that route. I think it's been talked about to death, but we wanted to find just a different way to do it. And, one of the first libraries that we stumbled across was from a guy named well, actually Z Serge on GitHub, you can look him up. And he built basically a C, some Objective C in there for connecting to the various web views on the platforms, right? So instead of every app shipping an entire Chromium instance, we were just going to use the web views on the system. You know, Windows now has WebView 2, and Mac is using WK WebKit, and on Linux you have WebKit GTK, and it all sounds like WebView. It sounds like it's the same kind of thing, so it should work. And obviously, you know, the devil's in the details. We've been working on it for 3 years, and I think we finally have it, you know, battened down to the point where we're about to release the 1.0 next week, maybe. We're in the last RC, we hope. I mean, that's also a common thing to say, right? The last RC before the final release. But
what could go wrong?
We're really closing in on it. And you know, if you've read anything about the project Tauri or heard anything about it, maybe the two big things you've heard are the apps are stupid small and they try to be really secure. And you know, maybe to address this kind of perception about security, you could switch to the slides that are on there, TJ, and
yep,
and I'll just talk to you guys. Thanks. A little bit about, you know, this whole world of security problems that we're facing, right? And okay, we're using Rust, and then there's JavaScript, and everybody's always pointing fingers about, you know, it wasn't us that got hacked; it was Okta. It wasn't Okta, you know, like. It's now NPM farms for domain squatted modules, or someone gets an expired email address and is now able to publish those modules. And we did a lot of hard thinking and work into how we can like just be more secure, and we keep on getting punched. You know, like everybody's like, well, my app doesn't have to be secure. And that's when it kind of hit us, you know, that it's our job also to not only provide a great DX and an easy way to build apps, but also to educate people and inform them that it's it's everybody's responsibility. It's not just your responsibility as a developer. Every part of the ecosystem has to be responsible. And that's really what we're trying to do. We offer a set of tools that want you as a developer to be safer, and also your app's users, right? And so in order to verify our assumptions, we contracted out the most amazing auditing company I've ever had the pleasure of working with, called Radically Open Security. Look them up, book them, but don't do it right now because I have to book them for something else too. Just give me a couple weeks. And they did a horizontal and vertical audit. Do you know what that is, TJ? The horizontal and the vertical?
No, you should define that.
Sure. So a horizontal audit is when they look at all of the libraries in this project kind of in isolation. In a sense, it's like your unit testing for security auditing. You know, you're looking for things like code smell or improper sanitization and stuff like that. You know, like how does the system itself work? And a vertical audit is actually looking at something that is using this this library, this horizontal stuff. And so after they did their, I would say, 3 weeks of review on all of the dozens of modules, well, crates mostly, then they did a vertical review of one of our example apps where we showcase the API. And I'll get into the API in a bit when we switch over to the command line. But basically, they helped us identify over 40 issues in the code, really coming at it from not just a security perspective, but as pen testers, as people who know the tricks to get directory traversal. And I highly encourage you guys, if you're interested in kind of the approach to how we verified our security posture, you can go to the repo Tauri-apps/Tauri, and there's a folder there for audits, and you can read I think it's 75 pages that they put together, and also their review of our fixes, because obviously if there's 40 some issues, we have to fix that before we go stable. And it was a 7-month process. We came out of it with a couple brand new features that didn't exist before. We technically built a way to isolate the JavaScript running in the web view from the Rust core that is reached via a message passing boundary, using some really clever iframe trickery. It's a talk in and of itself. But I think the point I'm trying to make is we thought we were doing a great job, and we brought in some pen testers to help us actually just lock it down. And so, yeah.
Well, I think too, and you can correct me if I'm wrong with this, but anytime you're talking natively installable applications, your security, your potential of security problems goes up quite a bit from just something that's running on just a website that you access with a URL, because vulnerabilities can potentially give people access to things that they really shouldn't have access to. That's not totally possible. Like, a web app can't really get access to your file system or certain things, whereas a natively installable app, like, there's potential for a lot worse, I believe, once you start to get into an installation or an installable app.
You're absolutely right. I mean, your classic XSS cross-site scripting attack on a website can be fundamentally destructive on a desktop app, for example.
Yeah.
Right? Especially if you use JavaScript to call window.electron, for example. If you're exposing the electron space inside of the view, which is also kind of bad practice, but it's why the electron community, and they did a great job. It's why they have this 15 things that you have to do if you're going to publish your app, and still people think that it's not important to be secure. I guess it's something that maybe is becoming more relevant with I'm not going to say the increase of cyber attacks, because they've always been there. Maybe the attention on them, and the pervasiveness of how that affects us. And I really, it's kind of tongue in cheek to say, don't be a tool. Don't let your app be a vector to have someone get their stuff hacked. But it really is important. Maybe we could switch over to the command line screen, TJ, and I'll just jump right in and show you guys how to make a Tauri app. So
yep, I can see it. You might want to bump up your font size a notch or two for those of us that don't see super well.
Is that better?
Oh yeah, that's great. You could probably even go one size smaller than that. Okay. Looks good. Yeah,
great.
Perfect.
So basically, we created a module called Create Tauri App. It's a node module, and what it does is basically what you expect. You hit enter, and kind of gives you some helpful information, and then it says, what's your app name? You know what, I'm going to just call it React Demo, and let's call it, sure, Tauri App is fine. And then we give you a whole bunch of different options. Since I've been particularly testing Vite, I'm going to take that, and I'm going to add the API package. I need to. And then let's take React TS and hit yes. And so now it's basically getting its dependencies, setting up the folders, the templates, and it's still, can I hide that? Yeah, great. So it's done. I'm going to cd react demo and npm run Tauri dev just to validate that it works. And then I'll walk you through how this is all kind of set up.
Yeah. I'm assuming
So
too, like that's a crazy number of options of like frameworks and stuff you support. Is that just because at the end of the day you just have a web view, so like you don't have to put, because like how do you support 20 different ways for people to spin these things up?
we have recipes. I can show you. I'm not sure why, of course, the
We can save that if
Tauri
you want
app.
to switch to showing the apps, or you could throw it, if you throw it in the chat, I can share the link as well for people that want to check it out.
Wondering why that didn't exactly work.
I like to how I Google Tauri recipes and I get like actual recipes. It's pretty
There we
good.
go. So the recipes are here. Can I paste it here in the chat for you?
If you put it in the private chat, I can share it with everybody on the stream.
There you go.
Yep.
All right. So what's happening now is basically we kick off the dev server, and then we start the Tauri app shell, and then we basically point the app shell at the dev server. So let me just drag this over here. This is your classic Vite React app. I can click it and it does stuff. Now, down here, we also have a Rust console. So I'm just gonna cancel out of this because as an app, it's just like showing you the basic rendered HTML. So today, together with a friend from the Tauri team, we put together a little bit larger demo. Let me see, there it is. I can paste that for you over here too, in case people want to follow along from home. The things that you have to know about a Tauri app are, you all of you have to know what a package JSON is, right? It's where you get your dependencies, your dev dependencies, you got some scripts, you got some versions, and of course you can go wild with this kind of stuff by defining browser versions and all that kind of stuff. Rust has something similar. It's called Cargo Toml, and it uses the slightly better way to write configuration files. I mean, you can have comments in here. You like this, for example. And what I'm going to show you in a minute is how we would, shrink the app. But first, I just want to kind of walk you through the way to set up a Tauri app. And obviously, Tauri is going to have a lot of configurations here. This is kind of the way to get up and running. So if you do the create Tauri app approach, you have to tell it, or it will know which localhost port you're going to be looking at. And if you're doing it from scratch, you have to define this yourself. And so what you'll notice that is super useful is if you run, yarn Tauri dev or npm run Tauri dev, before it starts the Tauri, it will do this npm run dev command. So that's really, really practical because once your dev server is spun up, then the browser is going to have something to show. And then there's all kinds of information about, how are you going to build it for Debian? Then there's Mac OS. If you want to put it out, you have to sign it. And Windows, same thing. Are you using the private API? If you are, good luck on the App Store because you probably won't get accepted. But there are some things that you need for it. And then we have the allow list. And this is something that we're going to come back to pretty quickly. I'm just going to get rid of that. What this means is we are going to use all of the APIs that Tauri provides. It has a window API, it has a file system API, it has a command API. It has basically a ton of different APIs that you can use. And what you're going to find is a little kind of mental trick that we built into Tauri for you. In order to reduce your binary size, all you have to do is reduce the number of APIs that you're shipping. We're not shipping a Node.js runtime. We don't have to. We just ship the little pieces of Rust code that we need. In a sense, it's like your common tree shaking. You know, if you, let's see, where are we?
Are the bits of that like large enough that presumably they're big enough that they make a significant difference on your actual application size?
Well, I mean, listen, if we invoked everything from Tauri App's API right here instead of just the invoke export, obviously we're going to have more stuff being used. Okay, with a smart transpiler, if you import it, then it isn't used. Maybe it won't get shipped. Maybe it will. It's hard to tell unless you're a Webpack Pro or you write your own SWC stuff.
Yeah.
You've been there, and again, if that thing that you're importing has side effects, well, all bets are off. It's all going to be bundled anyway, and
yep.
By putting this into your Tauri configuration, what we're saying is give them everything, and this is actually kind of useful at the beginning when you're just getting your app up, because otherwise stuff just isn't going to work, and you're going to be kind of scratching your head. Why won't the window close? I want the window to close, but you haven't given the app the functional code to actually perform that, right?
Yeah.
And so by teaching people that small is good, we're also helping them remove this attack layer that can get in there. Anyway, so I'm not going to talk too much about how React works. You know that. You know TypeScript. I'm going to try and explain a little bit more about how Rust works. So basically, you have in binaries that you create, you have a source folder and you have a main RS. That's just kind of convention. I suppose you could change that with your cargo config or whatever, but this is convention, and this is where people know to go. Now, if you're writing a library, on the other hand, you're probably going to have a lib.rs. And again, it's convention. And so this use Tauri window kind of import statement is exactly that. It's telling, let's see, it's basically the same type of thing as your import right there. So okay. This use Tauri, that's kind of the namespace of the thing that we want to use. We're telling it to, yeah, we want the window builder, we want the app handle, and the window URL. Great. And then we create a little function. You guys know functions. You basically define your variables, and in this case, we're kind of passing a context, and then what you expect to get back. And in this context, we want to have, I'm just going to make that wider. Make it a little bit smaller so I can see. I hope you don't mind.
Yeah, no, that's cool.
So in this context, basically overlay window, I think it sounds clear what it is. We don't want decorations. We want it to be transparent. We want it to be maximized. And then build at the end means, yeah, just do it. And then we've got a result here. So basically, either it's going to work or it's not going to work, because we handle our errors explicitly. And then we start the Tauri app, and then we basically run the context. And you notice here, this little thing, Tauri command.
Yeah.
Well, we allow you to kind of create your own commands. If you want to do something particular in Rust that would just be too complicated or impossible to do in the TypeScript, JavaScript world, we have this kind of Tauri command. So it's called open overlay window. Now, let's go to app.ts, excuse me. Yeah, I have to open it up again. So you see open overlay window is right here, right?
Oh,
so
wow.
Basically,
okay.
What we did is we created a function that Tauri listens to. when you click invoke, or when this invoke handler is evaluated, then it uses this Tauri magic under the hood to send a message across the window external message passing bus to the Rust core. Rust core is listening for this command. When it gets that command, it's going to execute this thing. So what's your best guess? What's going to happen when I click the button that says click me?
Well, I mean, I believe it, based off what you have there, it will open a window, because it looks like that's what it's doing. I'm sort of fascinated by it, though, because that does appear to be a little bit of a black magic, that it goes from one environment to another as seamlessly as calling a function with the same name. And I say that as someone, like, I'm relatively familiar with React Native. I also worked on this project called NativeScript that takes a somewhat similar approach of using web views. And in both those projects, they try to make this sort of thing easy, but it was never quite as easy as like a string.
All right, so
being the communication layer between the two.
I'm going to click me, and you're right. We opened up a window, and it's a full screen window, and we've got lots of confetti going around, and I can close it, and I can kill the app. Okay. So, I mean, there's not that much stuff going on here. We don't have like a GQL interface. We didn't bind into any kind of secrets management. We're not doing any remote calls. It's a pretty simple app. And so I'm going to just have you guess what the size of the app is going to be. How big do you, I'm going to bundle it for Mac OS, and I'm not going to use the DMG tree, just the app itself. What do you think the app's going to be?
Mm-hmm. Oh, man. There's always a few, like, I don't know, because I feel like you're somewhat trying to trick me, because normally I'm going to try to take that out of the equation, because normally you can expect any sort of app that ships natively to be at least several megabytes. Mm-hmm. I know the Rust code that's going to be bundled up has to contain something, and there's some stuff that you sort of have to package to be able to just access the web views. So I'll go with like 10 megs.
Okay. If it was Electron, what do you think the size would be? If
Chromium's big. I feel like Electron itself, like maybe 50 megs to throw in Chromium. I don't know. You could you can tell me how good these guesses are.
I mean, no, you're doing great. So basically, while we've been having this conversation, we ran our build phase for the HTML, JS, CSS assets according to React, transpile, RTS, et cetera, et cetera. Then we ran we bundled the Rust code all together in a production mode, and I'll just drag it over. Not bad. 6.8 megabytes. Now, I'm going to actually start.
That's incredibly small. Like I said, my guess was kind of artificially smaller because I knew you were trying to show that it's a small app. Because I think what a lot of people that for anybody watching this too, because I think JavaScript developers think like, because a 6 meg app on the web would be considered big potentially, but you have to remember this is like a native binary essentially for Windows, Mac, Linux. That's incredibly small.
Right. So, but I promised you that we would get it even smaller, and I'll explain why. But now that we've kind of got this console going, I'm going to show you a couple things that I always like to do. And first and foremost, we go to the Tauri config, and like I said before, only use the spelling that you know to be true. No, the things you need. Like, you don't need to ship fetch in your app if you're never going to fetch anything, right? And it's the same case here, where the only thing I really need to do is to be able to interact with this spawned window, right? That's all I need for this app. And I'm going to run the build command again, and I'll keep the this folder here in place. And again, it zips right through the compilation phase. And now it's one thing it's nice to remember about Rust. You are always recompiling your app. But once Rust has already compiled things, it kind of keeps them in a cache. And I'm not going to lie, if you don't do a little bit of housekeeping, these projects can get really big because Rust wants to optimistically keep things around. I've heard rumors that it's going to be getting better in the near future.
Yeah. Also, your Xcode projects for like Mac OS apps can also get out of control very quickly too. So it's sort of the nature of the beast when you start developing desktop apps.
So listen, you asked how big the API is. Well, the shape of it in Rust is over a megabyte, right? So now we're looking at 4.8. And in order to verify that I'm not just talking out of my backside, I will verify that each app works, that I am able to properly close the window and close the app. So that's kind of a quick manual test that yes, it's working. But I promised you more, and this is kind of where stuff gets exciting for me because in JavaScript land, you've got this JIT, right? The just-in-time compilation phase that tries to optimistically enhance loop functionality by having experience in it. And it's not machine learning, but it's really clever. Nevertheless, we can tell Rust how we want to get better. So one of the things we're going to do is in apps, you sometimes want to have, nobody wants to have panics, which is basically when the system seg faults, Stack Overflows, nothing works anymore. Sometimes it is useful to get that deep insight, but not always. I mean, if it crashed, it crashed. Figure it out in your integration testing, guys. But it can be useful in some cases. Generally, though, it's a waste of code, especially if you don't care about it. So we're removing the granular details about which line of which function failed, which also makes introspection into the app a little bit more complicated or less transparent. We're using code gen units, which is one, which we're using in order to just say, hey, single thread it. Rust, you're fast, but just single thread this for us. LTO is link time optimizations, or link to optimizations, which allows the compiler to kind of define how it moves through the functions. And opt level S is again another kind of black magic that is sometimes it works, sometimes opt level Z is better. It's kind of choose your own adventure on this, but as a reminder, we have 4.8 megabytes. Okay, so I just prepared a release style for the app, and I'm going to build it again. Now, of course, the Vite is going to go just as fast. We do have to, again, compile our binary, and this takes a little bit longer than the last time because we're only using one code gen unit. And the reason why that works, maybe I can even finish the sentence before the app finishes building, but the reason why that works is because that code gen unit knows everything that it's done. Whereas if you multi-thread it, you're not going to know, like one is going to be starting on something and another one's going to be starting on something else. And they might have divergent understandings of how the whole system fits together. But if it's all being done in one thread, then that thread is able to have complete understanding about how all the pieces fit together. And I mean, it might be a couple kilobytes, but holy geez, we just made 3.2 megabytes. So
Holy
basically
crap.
with these two things that we just did, we reduced our API surface area, which reduced our attack area. We threw away some useless stuff that Rust wanted to help us with, but then we used a smarter, albeit slower, I'm not going to call it a compression technique, but it kind of is.
Yeah.
And then we got this same app. I mean, It's pretty fast. I think it also still works. I don't see any visual changes. And I will tell you that the reason why this app is over 3 MB is because we're using some last minute non-enhanced SVG that's just like bloating the heck out of it. I'll show it to you. Let me just close this down. And oh, you know what? I'm going to start it back up again because I wanted to show you the memory consumption.
I'm curious to go ahead and finish your thought on memory. Then I have a question about like app size for like Electron and stuff too, if you're going to get into that.
Sure. I'm just going to do this so we can kind of watch how our memory is doing. And yeah, okay, it spawned a couple threads, but it's already self-correcting. By the way, Tauri localhost is a custom protocol that we're using so that we don't actually have to ship with any kind of HTTP server. Well, I mean, nothing like Express or that kind of stuff. So maybe what we can do is jump over to your questions and we'll just leave this kind of memory thing in the background. I'll close it and open it up again. And I mean, either you could ask me some questions or I could finish off the environmental part of the slide deck.
Let's do a couple questions and then you can jump over. And if anybody watching this has questions, feel free to chime in as well. So I am curious because what is Chromium's footprint for Electron? Because I just, as you were talking, I took a quick peek and all the things that I know on my desk, on my computer that I've installed that are either Electron based or, Chromium based in some capacity, all these things are like over 300 megabytes. And obviously they have a lot of other business logic and stuff at all. But I'm curious, like, what does just Chromium like add to a binary out of the just in and of itself?
My gut reaction says 40 to 50 megs.
Okay, that's kind of what I thought too.
My gut reaction to the Node.js that's shipped with it is also around 10 megs. And I mean, at that size, who cares, right? Like if you're already weighing in around 100 megabytes, who cares about making your code smaller and compressing your images if you're already going to be over 200 at some point, right?
Yeah, I feel like a lot of these apps have just like they reached a certain threshold where they just sort of gave up and are just like, well, the app size is what it is, and they throw it out there. Yeah. Which I know you're going to get into your slides. I do have one other question about how all of this works. The Rust code there that's doing like the window management, how does that magically know how to speak like Mac, Windows, and Linux? Is that Tauri code that under the hood is like written in like Objective-C /
Nope, it's Rust.
It's all Rust. So these are like community Rust libraries that help you access some of these things, or?
Well, let me show you. So basically, maybe I can make it a little bit bigger. So basically, Tauri is composed of 3 kind of layers. So the first thing we always have to do is we have to have a window, right? No matter where you are on desktop, you need a window or you don't exist. Okay, maybe you could get away with something like a taskbar. It could be argued that a taskbar is still a window, but the 95% of all of the apps out there are going to need a window. And that's what Tau is for us. It's a library that we wrote, and it has, don't look at Android and iOS, but it does have Android and iOS. It has Mac OS, Unix, and Windows. And basically, we can just kind of jump quickly in there. What you're going to see is very familiar things, right? Use Cocoa AppKit, right? And then for Windows, you're going to see WebView 2 kinds of things, right? Win32, Foundation, HWND, and then for Unix, yeah. this is the point that I think a lot of people don't realize. Like the simplicity of the Mac ecosystem, the simplicity of the Windows ecosystem. You've got 3 versions, maybe 4 versions, right? Linux has operating systems. It has window managers. It has different types of drivers. It has, I mean, some of them don't even have the notion of taskbar anymore, right? And so if you start to think about, it's something we absolutely overlooked when we started. We were just like, yeah, it's Linux, come on. And obviously the guy who's running Arch is not the same as the girl running NixOS. It's not the same as the grandma running Ubuntu. It's literally a different operating system almost every time. And we're lucky that WebKit GTK works so well. And yet it's literally the only thing that doesn't have WebRTC yet.
Yeah.
And we could compile it and then ship it, and then your Linux apps are suddenly 50 megabytes or bigger, right? And then you have all of the packaging stuff. Like, how do you package properly for Linux? And I know there's discussions. Everybody has an opinion, and I'm not going to get involved. I'm happy with the Debian package, but other people aren't. So anyway, that kind of is the first answer to your question. You have to have a window, right? And that's what Tau does.
Okay.
Then we have Rye, which actually integrates the WebView stuff into Tau, right? So you start with a window, and then you put in the WebView. And again, we have WebKit GTK, WebView 2, WK WebView, and Android. You might not know this, but we do expect to have full mobile compatibility around June, as for the adventurous, and probably audited and landing in the 2.0 by the end of the year.
Dang.
And so, I mean, as you know, WebView 2 again is it's a Rust interface to the Windows version of the WebView, which is based on a 7-letter word. It's based on Chromium, but we aren't shipping it. Right? It's kind of we thought for a long time, this is great. We just have to work out these 3 platforms, and obviously it's something that we have to maintain for a long time. And then, I don't know if you've done much web dev. I assume you have, since this is the channel we're on.
Yeah.
Do you know how much CSS exists on Safari? Is it all of it?
I mean, most of it.
I mean, I know that Tauri supports ES 2021. What's your go-to version of JavaScript that you render down to?
Oh man, anymore? I'd have to look. But the thing is, it's funny because TypeScript kind of like obfuscates that for you. Like, what is like? Yes, they're year based now. I could bring up an app I work on, see what it's set to. CSS is harder too because they drop the like clear and easy version numbers. So,
yep.
Let me see.
But anyway, I think the challenge we've been facing is exactly this. Like, how do you maintain the kind of deep integration with all of these platforms that have their individual nuances, not only from a programmatic point of view, also from a platform point of view, and then from a rendering point of view, right? And I mean, I've been doing this stuff long enough. I know that's why there's things called polyfills, and I know that you have to do your testing on the devices that you want to run it on. And even if you're just building for the web, you still have to make sure that it works everywhere, right?
And I think desktop it's that on a whole different level than from what web developers are used to, especially newer web developers. Back in the day on the web, there was definitely an era where you couldn't trust anything to work on any browser. Like, you had to be very diligent about testing. But I feel like nowadays in web dev, most things just work. Like it's kind of like more of an edge case if you get into something, or you have to be like on the cutting edge, right? If you're using something, some new API that just came out, sure. In that case, you have to be a little bit careful about how you deploy it, what you're doing with things like that. But for the most part in webland, your common features just work. Whereas man, on desktop, like things work so differently, and like it's totally possible. Like browsers now pretty much auto update, whereas like desktop OSs, like people could be coming with who knows what and trying to install and use your apps. Actually, that does lead me. I am really curious about how you test Tauri for some of this stuff. Like, do you have like some like what platforms do you like personally try to run things on? Like, do you have like a CI system that tries to deploy or like automate build this? Because like that just seems like sheer madness to me.
Well, I mean, there's a lot of things that you have to kind of touch there. So, at one of the companies where I work, we actually are using Tauri and have been for a while. And our approach is we've built. I mean, the Tauri team has built a Tauri driver, which is based on the WebDriver IO framework, so that you can drive the Tauri app with your Jasmine tests, right?
Yeah.
And or whatever flavor of test markup you want to use that is compatible with WebDriver IO. And we do that in our automation step. So basically, like you lint on every commit, and then or you lint and test. You lint and you format on every commit, and then you run your tests on a merge. And the thing is, we kind of ran out of gas a little bit on getting Mac OS WebDriver to work. It does work on Windows. Anyone out there who wants to help and get involved, we would love some assistance with Mac OS WebDriver.
Yeah.
And yeah, and then once it qualifies for whatever features just got gated in, then we hand off to human QA. And what we've found is not only does that catch things that you're maybe not expecting to happen as a dev, or something that you thought was so painfully obvious, but they couldn't get it to work. So you get this kind of UX testing, and then you also have your whole list of things that you have to qualify. And in that context, I really think that the human interaction with the app is really ultimately much more relevant. The reason why we do this with Linux is it allows us to fail fast. If one of the tests fails or the visual regression shows something is borked, then we don't even hand off to the QA, right? It just allows us to keep that cycle a lot tighter.
Interesting. I feel like I'd ask you questions all day, but I know you wanted to end by talking a little bit about the environmental stuff. So I'll let you get to that and show that off.
Oh yeah, sure. Do you want to go take it? Wait, before you do that, let me just make sure I'm on the right slide. Yeah, go ahead.
All right. It is now up.
Yeah, and so like it sounds super silly to even talk about the environment while there's a raging war going on in the middle of a pandemic. But I guess the thing that has always been on our minds is that we can't lose sight of our environmental goals. We cannot. Everyone has to work. Everybody has to work on it. And that includes all the developers out there. And this is a real snapshot of a real Tauri app. You can literally get them that small if you like make tiny icons and ICNS files are properly one colored. You can go really, really small. And that's a fun game. I mean, in the team, we do some code golfing to see who can get the smallest app. This one is the current winner. And if you go to the link at the bottom, you'll get a bunch of recommendations that we make to help you make the app smaller. But the reason why this is so critical is, you looked at your operating system, TJ, and you saw that most of the apps that you use that are Electron apps come in at around 300 to 600, 700 megabytes.
Yep.
And I know we've been trained as web engineers to send less traffic, to compress the image resources and send css.gz wherever we can, and do our best there. But just a kind of anecdote that got us thinking about this. One of the guys in the team, not going to say who, worked at a very popular, till it got shut down, a very popular application that allowed you to play videos on your computer while you were torrenting. It was super popular. The world loved it. Unfortunately, copyright law didn't. And Big Law, for all of their successes and failures, kind of shut the project down. But the interesting thing was thinking about success, right? So I'm totally going to skew the numbers because this was a conversation we had a couple of years ago. But basically, you have to imagine an update cycle that's every week. So every week, you're updating an entire Electron app that weighs in around 300 megabytes, 200, 300, I think at the time, something like that.
Yep.
And you've got millions of people downloading it around the world, right? Which is great. You've got massive traction. The problem comes when you start to actually do your transit calculation and you realize, well, my DigitalOcean droplet isn't going to cut it. There's just not enough bandwidth to saturate all of the requests. And then you start, building out a Cloudflare distribution system, or, back then it was actually kind of mirrors that would pop up, right? So you could get it from the latest mirror, and they didn't last long, right? Because these guys were hitting 30, 40, 50, 60 terabytes a month. And if you're a popular mirror, back then traffic wasn't unlimited in a lot of cases, and you would not just get throttled, you just get cut off. And I mean, you still have that problem today. And I think even more so today, companies are charging you more for traffic. For ingress, not so much. For what goes out, definitely a lot more, because they can't control it, right? And so you can literally become a victim of your own success. But if we start to think about this whole ecosystem from the perspective of we are people using each other's apps and downloading them and getting updates and all of this other great stuff, there's a real energetic impact that happens because of people merely transiting. And like, I've tried to be realistic about these numbers. I know that there's maybe better studies out there, but as a team, we kind of came to the agreement that these numbers are pretty close. And if you just think for a second that your hobby Electron app that you put up on GitHub gets downloaded 1,000 times, even if GitHub is paying the cost of the electricity and the transit, you just created, like, you are directly responsible for 72 trees that need to be planted. And I mean, we could get into what planting trees means, and that it's going to take 20 years till they're mature, and how much a scam the whole carbon system is. But the fact of the matter is, using internet costs real, or has real physical impacts on our planet. And that's what I hope kind of hits home. Everybody wants a more secure app, but I promise you, everybody wants a planet too. And we really, really, really can work together. And I think that, hey, maybe Tauri's time in the sun is for the next couple of years. Maybe it lives as long as Electron has. Maybe something better comes along. But I tell you, if it's not smaller and more secure, I won't use it. That's just what I've come to accept and expect.
Yeah, it really resonates with me, especially you mentioned that it's it's funny to me because on the web in general, we are very cognizant of file sizes and like it's a very big thing. People put all sorts of crazy complex techniques for keeping their file sizes small. But for some reason, once we move on to app land, whether it's desktop apps or mobile apps, where this is
Right.
100, this is perhaps even worse. Like suddenly, a lot of those rules just get thrown out. Like these apps are just ballooning in size, and no one really seems to care. And there's always a cost to that. Like there's an environmental cost, but there's also like a cost on your business. Like you said,
Right.
cost on hosting costs on like there's always going to be some users too that you lose the bigger apps you get because certain people don't have devices that can handle some of these things, or maybe it'll take them 2 hours to download this stupid thing and they'll never try your app because they gave it up. So like there's there's benefits on both
16
sides.
gigs of RAM. I need 16 gigs of RAM on my desktop, or I cannot use the computer the way I'm used to using it. And why is that?
Yeah. It's because you have 17 instances of Chromium running, though.
Yeah.
They're not going to run themselves.
I mean, I'm absolutely not a conspiracy theorist. I'm a firm believer in finding ways to do better. And I hope that Tauri is really able to contribute to that.
I think it's a good note to sort of wrap up on, because I know you got to take off here. The very last thing I'd like to do is I'd like you to give us like what I call like a link dump, right? So if people are interested in what you had to say, where should we send them? Like the website, or there anything you'd like to recommend?
Discord
tutorials.
Like
Discord.
I mean, the reason why is I'll try to be quick, but basically we've been in beta so long that one of our great advisors early on said, don't waste time making tutorials that are going to be broken in 3 months. When you come out with tutorials, they have to work. And now that we're closing in on 1.0, we are going to be doubling down on that. What this has turned into, though, is that the greatest knowledge about our ecosystem is inside of the community itself. And the Discord is really active. There's a lot of people who know a ton about this system and bring in other domain knowledge. And you meet people from React, you meet people from Dominator, you meet people from Svelte, people from the Rust compiler group. And it's a really exciting place to come and ask questions and learn about what the other people are doing. So I'll paste that here.
I've already got you, man. I've got it in the chat. It's very Googleable, and you got 930 people online right now, which is impressive. So very cool.
Yeah, man.
Awesome.
I think that I'm really happy that you had me on the show today. Thanks, TJ.
No, and you didn't bring it up, but your library's had a lot of success recently. You've did pretty good in State of JavaScript survey, some more downloads. So I wish you all the best, man. I think this is really exciting. I think Electron needed to be kicked a little bit too, to give them some pressure to improve as well. So I hope.
I think they did a great job. I learned a lot about development working with Electron, and I know they're learning stuff from us too. So
that's the way it's supposed to work, right? Like no shame on them. They've done an important thing for the community. Exactly. They've enabled a lot of people to build cool stuff, but they need to be pushed to innovate and keep up as well. And I think you all are doing an awesome job at that. So I wish you the best.
All right.
Cool.
Thanks, TJ.
Thanks everybody for joining. Until next week on React Wednesdays.
Ciao.